we can start, Daniel, wherever you guys are ready.
Okay, give me just a second. I will share the screen. This one. Yes. Okay, can you see the screen?
Yes.
Okay.
Okay. Hello everyone, my name is Silvio. I'm working with Daniele and I'm going to present very briefly an introduction of Fogatras, that is our platform for fog computing. Then I would say the interesting part will be presented by Daniele, that is the demo of Fogatras. So, basically the idea is to present, the classical 5W question for better understanding what is Fogatras. First of all, who we are? Well, we are first of all a research unit called Rising. Rising stands for Robust and Secure Distributed Computing. We are basically working on distributed computing and on the cloud to thing continuum from a research point of view. In particular, we are part of a big research center that is called Fondazione Bruno Kessler. We are located in the north part of Italy, near Venice, to give you an idea. But then you need a demo, you will see a map and you will see exactly where we are located. So, what is Fogatras? As I said, it's a software platform for managing fog computing infrastructure. In particular, with Fogatras, you should be able to set up, operate, manage a distributed computing infrastructure. You should be able to deploy containerized application in an automatic or semi-automatic way. And you should also be able to model the workload and intelligently, smartly, let me say, place that workload. Last but not least, this is still experimental as a feature, but we introduced it in Fogatras in the last few months. The idea is to provide also a sort of negotiation of the resources between the infrastructure owner and the developer, and a price for each resource. Then you need a demo, you will see something about this. Okay. Where can Fogatras be applied? As you know, fog computing can be applied in different verticals. I listed here some of these verticals, probably there are more. What I will say now is that we focused in particular on two verticals. One is Industry 4.0 and the other one is a Smart City. And in particular, Smart City is the vertical that you will see during the demo. Okay, why Fogatras? Well, the idea behind Fogatras is basically to consider to take the open source technology, the mainstream, currently mainstream open source technology in the cloud context like OpenStack, Docker, Kubernetes, Ansible, and so on and so forth, and try to extend them from cloud computing management to fog management, so as to provide a sort of seamless transition for the user between from cloud management to distributed cloud and fog management. So in this context, owners and developers should be able to easily deploy the workload on such a distributed infrastructure, considering not only traditional requirements like the computational one, CPU, RAM, disk, etc., but also network-related ones like bandwidth, latency, jitter, and so on and so forth. And the last but not least, we see Fogatras also as a way to virtualize and softwareize commodity hardware. Let me give you an example. Let's take a camera, for example. Such a camera can be connected to a fog node, to an edge node, and depending on the software that on demand you can deploy on that fog node, that camera can be used, for example, for tracking a vehicle. If you deploy a service that provides license plate detection, or on the opposite, if you want to track a person or to do some security checks, you can deploy a piece of software that instead of doing license plate detection does, I do not know, but face detection, for example. And so today you can use that camera for a given scenario or use case, and tomorrow you can use it for another use case, or for both of them, of course. And we think that this is interesting added value that Fogatras can provide, such a virtualization and softwareization also of hardware that is a commodity at the moment. Okay, regarding the timing, the roadmap of Fogatras, we started to conceive it a couple of years ago in the context of H2020 European or research funded projects. We demoed it last year in different venues, in particular the OpenStack Italy Day and at the Fog World Congress in California last year. And we wrote also a couple of papers on Fogatras on one of, or if I recall correctly, on both of them, the name was not Fogatras, but Fogit. It was the former name of Fogatras. You have the reference if you want to check them here to the two papers. The current TRL of Fogatras is 4. So basically, we tested it in a lab environment. But we are a pilot that is ongoing with an industry here in Italy in the context of Industry 4.0. And for the future, we plan to, for sure, finalize and enhance some functionalities, in particular the ones related with usability and front end, and to experiment to improve, the TRL, as I said before, of Fogatras through the POC, proof of context, in environments that are more relevant than as a simple laboratory environment. Okay, more or less this is for the introduction. I will leave the floor now to Daniel for the demo. If there are questions, of course, feel free to ask.
Yeah. Okay, let's start with the demo, but before, give me a couple of minutes to give you a quick introduction on the context. The context, as said by Silvio, is the one of smart placement. Basically, with Fogatras, we are trying to optimize the usage both of the physical infrastructure, but also we try to respect traditional, but more important, non-traditional requirements imposed by the application developer or the application provider. The reference scenario is the one of the smart cities, and the use case that can be enabled are, for example, the one of traffic control, city security, or everything that is that involves, for example, video streaming or video pattern recognition at the edge. But not only. The reference infrastructure that you will see is an emulated infrastructure in our lab, but represent a real infrastructure we have here in Trento. This is the picture that summarizes the infrastructure. As you can see, we use this infrastructure to do experiments and to do demos. And as you can see, we have 5 different regions. Each region represents one Kubernetes worker node or an aggregation of many Kubernetes workers. They can be virtual machine, hardware, or yeah, small piece, mini computer or bigger hardware, and yeah. Moreover, each region represents a suburb in our city, in the Trento city. As you can see, Povo, Mesiano, and Vela are just a suburb of the main city that is Trento. And yeah, we classified the region in 3 tiers, but Fogatras supports also more tiers. And as you can see, the tiers are used to classify the computational resources that, as you can see on the top, are higher, and they decrease as soon as we reach the edge. Also, we can note also the links. Here we have the links that connects the region, interconnects the region at the edge that have, of course, usually have high bandwidth and low latency. But instead, the links that interconnect the edge to the cloud usually have low bandwidth and high latency. Finally, we have camera that are directly attached to the region that are at the edge, in the edge tier. We will see the deploy of a particular application that is composed by 3 microservices. The microservices are components that provide a specific role on a big application. So we have a chain of microservices. If you look at the picture on the right, we have the green box, for example, could be a microservice that extract image from a video stream of a face or of a plate, of a car plate. The yellow one could, for example, recognize the plate or the face, and the red one could provide some analytics or machine learning or anything that does not need strictly network requirement towards the endpoint that is the camera. We classified the application that you will see deployed on the infrastructure in 2 categories. The first one is the traditional cloud native application that in this application we do not provide requirement on the network, but only computational requirements. And later you will see also a deployment of IoT and data-centric application in which we provide a specific network requirement between the camera and the first component, the first microservice, and also between the first and the second to the third. As said before, the reference scenario is the one of the smart cities. And yeah, so this is a bit to these slides, and the next one want just to show you what you will see later in detail. The microservice, the name of the microservice, the first part of the name, small, represents the computational requirements, while the second part represents the network requirements. For example, here we have 3 microservices deployed in the application, and yeah, and the green one has a small requirement in terms of basically the color of the box represents the computational requirements, while you will see later the capital letter inside the box represent the requirement of networking between the containers, between the microservices. Okay, what you will see in the demo, you will see a first phase in which we will deploy a traditional application, 3 traditional applications composed each one by 3 microservices. And one of these microservices needed to connect to a camera, camera 1, camera 2, and camera 3 that are directly connected, if you remember the picture before, that are directly connected to region Vela, Mesiano, and Povo. You will see that all the microservices will be deployed on the cloud. While on the second phase, we will deploy an IoT-centric application specifying the requirements, the network requirements between each component. And you will see that in this case, all the microservices will be distributed on the infrastructure. You will see also that hard constraint, like the one of latency, is achieved in a specific and particular case. Okay, so this is the first phase. Basically, we have the application composed by 3 microservices. What we will see that everything will be deployed on the cloud, and the network link between the edge and the cloud will be used for communication. While in the second phase, using Fogatras and thanks to the specification of network requirements, we will be able to deploy the microservices in a distributed way using better links for microservice to microservice communication. Okay, so we can switch to live demo. Silvio, if you can copy the link, we will give you a couple of links in the chat to follow our dashboard. I will show the dashboard on the shared screen, but you can also follow on your laptop. Okay, can you see the new screen now, or should I switch the window on the?
Yeah, it's good.
Okay, okay. So, okay, this is the Fogatras dashboard. Let me start. Okay. So, okay. Now I just zoomed in to our city on the map. Okay, Fogatras is an application composed by many microservices and currently is running on the cloud region. But to avoid complexity, I will disable the listing of these components on the dashboard. So we will concentrate on the components that are specific of the use case. As you can see, we have this icon representing the 3 tier we showed before, and we can see that in these 3 edge, Vela, Mesiano, and Povo, we have cameras. We simulate cameras connected to these specific regions. Okay, let me start first phase. So in the first phase, we will deploy traditional application. So you will see the deployment of 3 different traditional applications composed each one by 3 different microservices, one with small requirements in terms of computing, one with medium requirement, and the other one with big requirements in terms of computing. As you can see, we can see that big, medium, and small are microservices are all deployed on the cloud. And of course, in this case, all the streaming that comes from camera 1, camera 2, and camera 3 use these specific links that have low bandwidth. So you are, in some way, you are congesting these links. So, okay, now let me prepare the second phase. In the second phase, we will, okay, to prepare the second phase, I have to undeploy all the applications that are currently running. So, okay, now it's completed. Okay, you see this script here on the shell is just a script to be able to reproduce the demo quickly, but behind the scenes, this is using our command line interface and communicates with the Fogatras API. Okay, so now I want to deploy IoT-centric application. In this case, we are submitting to the systems the deployment requests that are just a JSON representation of the microservices chain, specifying inside also the network requirements that have to be respected between all the components. And as you can see, for example, for camera 2, we have that the small the microservice that have small computing requirements is deployed on this small on this node at the edge. Also because it has higher network requirement in terms of bandwidth and latency towards the camera that is connected to this region, that is camera 2. The intermediate component is deployed on Trento. That is the intermediate region. If you remember, we called it cloudlet before. And the components that does computation, high computation, or analytics, etc., is deployed on the cloud. In this way, the bandwidth usage is concentrated on the edge between this container and this one. Okay, so also we can see on the Grafana dashboard. Okay, we can see also on the Grafana dashboard that we have 3 components, 3 microservices deployed on the Trento region and just 1 on the remote region, the edge region, and we have 3 components also on the cloud. We can see in Grafana through this gauge, we can see the in percentage the computation, computing required, the computing status of the region. We can see also here an historical view of these computational resources. And as you can see here, we have the network resources. And for example, in the link between cloud and Trento, we have high usage of bandwidth. Yes, we have a high usage of bandwidth because basically all the microservices use this specific link, okay, from Trento to the cloud. And we can see also in this Grafana dashboard that the links between the remote region, Vela, Povo, Mesiano, towards the clouds are not used because all this traffic flow through the Trento, the cloudlet, the Trento region. Here at the end we can show you also the difference over the time of the resource pricing. Here we have the pricing.
Yeah, this is more or less the experimental feature I mentioned before. Just to give you an idea, see that when the application are deployed on the edge nodes, the unit price of the resources on the edge node increases because there is more demand and the resource is becoming more scarce in some way. And so you can think about the pricing as a way to balance the scarcity of the resources at the edge. So to some way avoid to exhaust the resources that are at the edge leaving no more resources for the next customer that is coming. This is more or less the idea. But, okay, go ahead.
Okay, so just to complete the demo, we will deploy a specific, an additional, a final, latest application with a specific requirement of latency between the first component, between the camera and the first microservice, and also the first to the second. Think about an example of this application could be I don't know, a gaming application at the edge, in which we have a first container that manage the streams that come from the camera, and the second container that does some calculation, but it needs very low latency to be able to respond in time to the player. Okay, this application will be deployed. Let me switch. Okay, this application will be deployed on Povo and will use the camera one. Okay, let me see. Of course, this application is composed by 3 microservices, the same as before. Yes. Okay. So now we can see that we specified a high requirement in terms of latency, meaning that from the components that communicate with the camera to the components that does some high computing calculation. We have specified a very low latency constraint. In this case, the intermediate component is not deployed on the Trento region, but is deployed on the very same region where the other components has been deployed. And we can also see in Grafana that, of course, the computational capacity, the computational resources on the Povo region have decreased, but we should see also that the price of this region increase, and also the link, yes. The link connecting Povo with the cloud, basically this link. Okay, so we have finished. If you have any question on this, we are open.
So one question, I don't know if you can open a couple of the deployments to show a little bit about what Kubernetes constructs you're using in the services and routing to get your network priority design. Like I understood sort of the narrative of it, but what does that look like in kind of YAML?
Okay, let me show you. Just a second, I will take the file. What I can show you, probably I can show you this one. IoT Appcam 2.1 Silvio is the one. No, maybe it's better this one. The one with latency. Yes, this one. Okay, can you see it?
Yes.
Okay, this is a deployment request that we send to the Fogatras API. In this deployment request, basically, we specify data flows between for example, this data flow. In this data flow, we specify the network requirements between the camera and the destination, destination microservice. And here we specify the bandwidth, and here we specify the latency. So we have data flows are basically the edge of a graph. Okay.
Yep. Very much a graph. Yeah.
Yeah. It's a sort of representation, graphical representation of a microservice chain. Okay.
Yep.
And here we have the node. Okay. So the microservices are the node, and here we specify all the computing requirements of the specific microservice.
Okay, and I see there that's the magic line there, right? Which has the entire resource, the Kubernetes resource in the.
Yeah, We currently we are including the Kubernetes spec of a deployment inside this object that is treated by Fogatras, that is the microservice. Okay, and based on the network requirement and the computing requirement, what does the Fogatras orchestrator is to add a specific I don't remember a specific constraint in terms of Kubernetes nodes. Basically, it had a node selector constraints.
And then how does the route with the requirements for network that you have described in the first graph for the cameras, are they so are the services using the traits, I mean the constraints for using certain services with like inside one of the microservices that's calling, so your source to destination?
That's a good question. Currently in this prototype, we only deploy an object that is a deployment. Okay. All the services enabling the interconnection between container have to be deployed before or have to be included inside this deployment descriptor. If this is the question, I don't know if I catch the question.
Yeah, no, I guess I'm saying imagine that you had a topology of your graph where your destinations are services that may exist running in different nodes. Like if you had your the middle tier that started with a T, I can't remember the name, but that middle tier, if there were several choices and a camera had multiple possible service pods to reach in a replicated deployment, whether it would figure out if there's any way to prefer the shortest latency that would meet its requirement.
Okay, yes.
Yeah, maybe if I understood well the question, I can try to answer. Basically, we have two models behind Fogatras. One is this shown now by Daniele on the screen, that is the model of the application. We consider an application as a graph composed by vertices and edges and links between two vertices. And we model in a quite simple way an application in this way. On the other side, we have the model, the topology of the infrastructure. So all the network links that link two different nodes, for example. And so each link has a set of properties that are, for example, the bandwidth, the latency, etc. The algorithm, the scheduler, basically, that runs inside Fogatras, basically tries to find the best place of a given microservice, considering both the requirements, from one side, the requirements of the microservices and of the data flow, and on the other side, the possible alternatives that we have in terms of networking that interconnect the different nodes. I do not know if I was able to answer.
I think so. So the alternatives, the way the graph kind of resolves with those alternatives is you're assuming you know in advance the performance of the links.
Exactly.
And you code those into the graph, as opposed to something that is more runtime or dynamic, where it's testing multiple edges in the graph to see which one is the best at that time. Okay. Well, and I know I know, again, like I've said in other presentations, this is an early stage discovery work. So just wanted to understand the design.
Okay.
Maybe addition from my side, so to make sure that I understood it correctly. This is Harold. So I understood that you have sort of Fog Atlas scheduler that takes that takes a graph description that represents the topology of your application, and then it adds sort of node selectors to the YAML file that you then give to the Kubernetes scheduler to schedule all the containers. Is that correct?
Yeah, that's correct.
Okay.
And basically, each region can be composed by one Kubernetes worker, but in a region we could also have many Kubernetes workers that are interconnected in the same layer 3 network. Okay, so basically what Fogatras does is to schedule and to place the container inside the region. Then it leaves to the Kubernetes scheduler decide which is the specific node where this microservice should be deployed. We use labels on the node
okay.
in order to, we have labels on the nodes to link this concept of region and aggregate basically many nodes inside, many or just one nodes inside one region.
Okay, understood. And you assume that the network capabilities are static, and you know in advance. So
yes, we assume that we know in advance the capability of the network, but on the other side, as you probably noted in Graphana dashboard, each time an application is deployed, you are going to consume some network capabilities in terms of bandwidth, for example. And so we are taking into account this for the next deployment. So basically, on the screen you see now the link between a cloud and the Povo was 200 kilobits, and now it's just 100 kilobits because we deploy an application, and so the capacity is the available capacity is less than the total.
okay, cool. And what you show in the Grafana dashboard, that is measured, so you monitor the network bandwidth and then you show it there.
Exactly. Exactly. The network bandwidth, the CPU, RAM, etc., etc. Yes. Let me also add that in this way, I mean, as it is implemented now, Fogatras is more or less a sort of wrapper of Kubernetes. That means that we wrap the scheduler of Kubernetes and the API of Kubernetes with, I mean, something that add this distributed functionality in terms of ability to handle network requirements.
Okay.
Another possible architectural solution could be to extend instead Kubernetes, the API of Kubernetes and the scheduler of Kubernetes, in order to do more or less the same thing, but not wrapping, instead, I mean, extending it.
So in other words, with the deployment file that you pass on to the Kubernetes scheduler, you restrict the degree of freedom of the scheduling decisions so that the networking requirements are always fulfilled.
Yeah, that's the point, yes.
Okay.
Yes. We use a sort of template of Kubernetes descriptor file, and then we modify it in order to pass something that will work in terms of network requirements when the Kubernetes scheduler will do its internal calculation. Yeah.
Okay, cool idea.
Okay. I can stop the screen sharing. Okay.
Hi, do you hear me? Can I ask a quick question, maybe?
Sure.
Yeah, sure.
So my name is Laurent. I'm working for a CR Wireless company, which is making, I mean, my team is working on creating IoT gateways. And so on your description on where the device were put on the map, some of your nodes were labeled tier 2, and they looked like smaller one devices, or at least computational resources. And I was wondering what kind of network links you were using between those tier 2 nodes and the other one. Are there like regular Ethernet links or more like fiber or?
Well, maybe I can answer them. Maybe Daniele can add more details. Well, at the moment, this is just, I mean, a demo in a lab. So everything is more or less emulated in a lab. So think about a set of virtual machines that are, I mean, deployed on a data center, and with Kubernetes above them, and so on and so forth. So we didn't, for this demo in particular, we didn't think about the real network link between the different tiers. Of course, what we did is to simulate the fact that the bandwidth can be more or less based on the link between the different tiers.
Yeah.
But it's not a real environment again.
Okay, I can completely get. I mean, you've done a very interesting thing on the. I mean, just the topics you were explaining before. I mean, the way you do an extra logical. To schedule the workloads above, I mean, using scheduling specifics. So maybe you focus more on that. And so, yeah, just do you plan to have important features on the nodes that you simulate currently, but maybe one day they won't be simulated? That are in tier 2, like do you plan to have services that needs to be always on those tier 2 nodes?
You mean services provided by the platform itself to be used by other application, or?
Yeah, I mean, maybe I will try just to clarify my question. My point is that if you do have some services that are linked to hardware capabilities, like having to connect to the camera, depending on where you do some of the services, maybe I missed some point in the beginning of the presentation, but if you do some kind of features like getting some image processing, or I don't know, maybe other things using the camera, but those services are deployed using Kubernetes. If you appear to have a small network issues, you might, I mean, that's my experience, see that those services might be removed from the node. So do you plan to, I mean, is this something that makes sense? And is that something you plan to like put apart some of the services as built-in outside from Kubernetes, or make the problem disappear with a custom solution, or I mean?
Yeah, very, very good question. Indeed, I mean, let me try to answer. I'm not sure to be able to completely answer, but of course, you touch a very interesting point, because we are in a distributed environment, and the connectivity cannot be always guaranteed. So at the moment in this architecture, we have the Kubernetes master that is running in cloud. So of course, if something happens on the link between the cloud and the edge, the Kubernetes master is no more able to talk with the Kubernetes workers and the other services. So our vision is more or less this. Even though you got a network fault, but the application, the user application, not the Kubernetes services, that you deployed through the Fogatras at the edge is developed in some, let me say, smart way, for example, in order to keep a cache of the video streaming that is collecting from the camera, then probably everything is working, because, I don't know, 10 minutes later, when the network lean comes back on, the remote part of the application, the microservice that is running on the edge, can again connect with the microservice that is running in cloud, and so they can start exchanging what was in cache, saved in cache.
Okay.
This is not true for the Kubernetes services, and for this reason, what we are thinking, but we didn't implement yet this, is to distribute also Kubernetes, so to have basically a sort of, federated Kubernetes, where we have, yes, a master in the cloud, but probably another master on the middle tier. So, in some way, everything should continue to work also if you lose the connectivity with the cloud. I don't know if this makes sense or not, but
yeah, I mean that's that's an interesting way to divide the problem, or I don't know to say that properly, but to reduce the constraints and put things. Ensure a couple of things are running correctly where you need them. So okay, thanks for the answer.
you're welcome.
Okay, if there's no any other questions, I think that would be it. Thank you guys for the presentation.
Thank you for the space.
No worries. Does anybody else have any other topics for today? We have 10 minutes left. Cool. Then have a nice weekend, everybody, and see you next time.
Thank you.
Or on Slack.
Bye-bye. Thank you.
Thank you. Goodbye.